Hi class, good morning. Hope you are all well. So today our lesson is going to be on energy sources. We were talking about electric circuits last week and you learned how to draw them. You learned the difference between parallel and series circuits. And so I wanted to go into a bit more detail with some of those components that make up a circuit. So today we're going to talk about energy sources. So the key question is, how are electrons moved around an electric circuit? We're going to be identifying, describing difference between a cell and a battery, and identifying, describing the different types of cells that are available, and also comparing and contrasting primary and secondary cells. So recall from last week, this is a diagram of a very simple electric circuit. As you should know by now, this is an example of a series circuit because there is only one path in which the electrons are able to flow around the circuit. Okay, so basically it is a circuit is a closed path along which electrons that are powered by an energy source can flow. And in this circuit, the energy source is basically a battery. Last week, you were given some diagrams to draw in which you had to include a cell or a battery or an AC alternating current power supply. So in this case, we have a battery, and a battery is basically, this particular battery is made up of two cells, and those two cells have a positive terminal and a negative terminal. And another thing that I wanted to go over was the difference between conventional current and the actual current, the actual direction in which the electrons flow. So conventional current is based on what scientists used to think about which particles are actually flowing through material, flowing through conductive materials. And they used to think that actually the protons were the ones that were moving. So now we know that it's not the protons, that it's the electrons that are moving around the circuit. And so we also know that the electrons are going to move from the negative terminal of the battery or cell around the circuit and complete it towards and end up back into the positive terminal of that cell or battery. So in this case, it's a battery. And basically, how does this happen? How do the electrons leave the battery in the first place? So the reason why they leave, it's because they're basically forced to leave. There's a number of chemical reactions that take place within a battery, within a cell, that force those electrons to kind of move to one end of that terminal, which is the negative end. And as you know, with the law of electric charges, when you have lots of like charges, they will repel each other. So if you have a buildup of electrons on this terminal, they will eventually leave that terminal if they can. And they will move along the wires, the conductive wires, because you need to have conductive material that allows electrons to flow in the first place. They will move into the circuit and through the wires and go around until they get to the positive terminal, because electrons are attracted to positive charges, because like charges repel, whereas opposite charges attract. So there's a number of chemical reactions that are taking place within that battery that are forcing this separation of charges. So along on this side, you have the positive terminal, and this is the negative terminal because of the fact that chemical reactions are taking place. What was I going to say? I forgot what I was going to say. I probably will come back to that in a bit. So there's chemical energy here that is being converted along the way into electrical energy and then light energy. And if we've got a motor in here somewhere, that chemical energy is being converted into kinetic energy or movement energy. So cells versus batteries. So most batteries are actually known or made up of what are known as voltaic cells, or there's another term called galvanic cells, and those two, voltaic and galvanic cells, basically mean the same thing. They're electrochemical cells, and they those names come from the people that basically made some kind of contribution to the whole idea of electrochemistry. And you can read about these people in your textbook as well. So a cell is basically just a source of energy that generates an electric current by chemical reactions involving two different metals. These are two different metals. They are definitely metals, but they're two different metals, and they have a difference. They're different because they have a different affinity for electrons. Some of them, one of them is going to have lose electrons, and some is and the other metal is going to gain electrons, because one has a tendency to lose and the other has a tendency to gain electrons. And these metals in a electrochemical cell are known as electrodes, and this is a cathode, which becomes positively charged, and this is an anode. This is a metal that becomes negatively charged because it gains electrons, and this one loses electrons. Okay, and so we'll get to that. We'll get to explaining this a little bit more detail in a bit. So remember, this is a symbol for a single cell. This is basically a diagram of a battery, and it's a cross section of what's inside. Battery is made up of a connection of at least two or more cells, and you have a positive terminal of this battery and a negative terminal of this battery, and inside there's this is the cathode. Basically, this is your electrode that is positively charged, and then right over here on the outside is an anode. Okay, so it works a little differently than the voltaic cell, but it's the same concept. And this is the symbol of a battery that's made up of 1, 2, 3, 4, 5, 6 cells. This is a typo because I added this diagram. I added a different diagram. I like this one better than the previous one that was in this PowerPoint. So this is 1, 2, 3, 4, 5, 6 cells, not 4. I should change that. So voltaic cells. So in a voltaic cell, the two terminal ends are called electrodes again. The electrodes are made of different metals that have different abilities to hold on to electrons, and these electrodes are immersed in a conducting solution or a paste. In the case of a dry cell, there's wet cells and then there's dry cells. So this conducting solution is known as an electrolyte. So this is an example of this voltaic cell or galvanic cell. And it basically is showing you, this diagram here, showing you that there are a bunch of oxidation reduction reactions that are taking place. And these are also known as redox reactions. And these are spontaneous reactions that happen by themselves when you have these electrodes placed within an electrolyte. Okay, so the anode here of a galvanic cell is negatively charged. Since the spontaneous oxidation at the anode is the source of the cell's electrons or negative charge, and the cathode here is the positive terminal. And oxidation takes place at the anode, and the electrons will flow from the anode to the cathode. Okay, there is a video that right over here that is a really good video, and it explains exactly what these oxidation reduction reactions are and how they take place to produce this circuit. Basically, this is a circuit, and you don't need to worry about this for grade 9 curriculum, but if you're interested in knowing exactly how that works, then this is an excellent link to a video that I found for you guys. So feel free to watch that. So there are two types of cells. Cells are classified as either dry cell or wet cell. And a dry cell is a cell that contains an electrolyte that is in a paste form. The original dry cell battery was the D cell battery made up of zinc and carbon electrodes. And most commonly used today are the alkaline cells, which last much longer than these zinc and carbon cells. Okay, this is an example of the zinc carbon D cell. Again, this is similar to the one that I showed you previously. This is the cathode. This over here is going to be the anode. And it's the right over here. This is the ammonium chloride. This is the electrolyte that is the paste in which those electrodes are placed within. This is an alkaline cell. It looks very similar, except for the negative electrode is zinc, and the positive electrode is manganese dioxide. A wet cell, the most cells that are used today are actually dry cells, but there's still some used that are wet. And the most common wet cell is one in which you find in car batteries. Okay, this is the sulfuric acid is used in certain car batteries, most batteries, and it is a liquid electrolyte. Okay, so right here, sulfuric acid in water solution, and then there's a lead plates that are separating the electrolyte. Okay, so another classification, in addition to wet and dry cells, we have primary cells or secondary cell. A primary cell is that one that I showed you right at the beginning, the simple one in which let me go back to the zinc carbon one, and these ones are, once the chemical reactions take place, once all the chemicals have been involved in those chemical reactions and they've all been used up, the cell is no longer viable, and you basically have to recycle it. You can't use it again. A secondary cell is one in which it can be recharged and reused many times. So basically you plug that secondary cell into a charger, and the electrochemical reactions that have taken place within the cell are reversed, so that those reactants can react again, and they will keep doing this until, it can't be charged anymore. In a secondary cell, the current is basically passed in the opposite direction through the cell from another source, and this basically reverses those chemical reactions, restoring the battery to its full capacity. Types of cells, there's a lithium ion cell, which is a secondary cell. This is used in many cell phones, laptops, computers, handheld video games. This is very, very common. And it can generally be recharged 300 to 400 times before, as you know, your cell phone, for example, stops charging or lasting as long after you charge it before it needs to be replaced altogether. This is an example of a lithium ion cell. These are all examples of voltaic cells. And a fuel cell is different. It's a cell that generates electricity through chemical reactions of fuel. Hydrogen fuel, for example, is one of the common ones. That is this chemical reactions. The fuel cell is stored outside of the cell. A solar cell is a cell that basically converts sunlight into electrical energy. Another type of cell. Okay, so those are the sources for your electrical circuits. Okay, and let me just go back to this diagram. So what you really need to know is that, most importantly, that there are chemical reactions that take place within the cells that separate those charges, that force basically the electrons to move to this negative terminal of the cell or battery, and then the positive charges don't move. You know that they don't move, and they remain there. So the electrons, as they go around the circuit, they are attracted to those positive charges on that other end of the battery. And there's a difference, a potential difference is created, and it's that potential difference, which is also known as voltage, that creates this ability to do work. And I'm going to talk to you more about that in another PowerPoint that I will be giving you guys probably on Wednesday. Anyways, I hope you have a wonderful day, and I will be posting some work along with this video lesson. Take care.